So in lab this week, we're going to be studying 4 different types of infrared devices. One of them can detect an object that's nearby. Another can detect motion of an object that's at quite a distance. Then we'll have an infrared communications link that's composed of a receiver and a transmitter. I've already pre-wired the board for all of the components of this lab, but we're just going to do the first one right now, which is the infrared proximity detector. So let me quickly upload this program. The proximity detector is the device over here, which is composed of an infrared transmitter and an infrared receiver. What happens is it'll send the signal out over the transmitter, it'll reflect off of an object, and then if it bounces back to the receiver, then we know that an object is nearby. So I'm going to kind of turn this up on its end so that you can see the motion. As I'm moving my hand in, it'll beep when it detects my hand. So now it is beeping when it's maybe, I'm going to ballpark it at maybe about 3 inches away. But here's the interesting thing is that because it's based on reflection, the actual reflectivity of the material can make a difference. So I have here a piece of white paper, and as I bring it in, I'd say that's closer to maybe 5 inches away that it's detecting that. But if I bring in a piece of black plastic that's not very shiny, so here I have a piece off of a printer, as I bring this in closer, now we're maybe 2 inches away. So it's just important to know that when you're working with an infrared proximity detector, it is not a rangefinder. It is detecting the presence or absence of reflected light, and that can be due to the range of the object, or it could also be due to the reflectivity of the object. We can also add the second detector here, which is a passive infrared motion detector. So you can see here we have this sort of little dome on the front here. That's actually a Fresnel lens, which is designed to focus all of the light down onto the sensor. So in this program, the proximity detector is still active, but now we also have a motion detector as well. So if I move my hand, I'll bring my hand in on the left side of the screen here. And as I do that, oh, it needed a second to reset. Okay. So now it goes off for 5 seconds. Once it detects something, it goes off for 5 seconds, and then it needs about 5 to 10 seconds to reset. And if I bring my hand in again, it detects it. I have 2 different tones. One for the proximity detector, which is aiming upward, and one for the motion detector, which is to the left. It has quite a wide range, so I don't even have to bring it in very far, and it'll detect the motion. Another thing to know is that, let's see, one more time. There we go. Another thing to know is that the proximity detector, while it can detect an object that's a few inches away, the passive infrared motion detector can detect objects that are 20 or 30 feet away. And so I've been working on this circuit, and when a student walks by in the hallway, it'll actually trigger. So it's quite good for long distance detection of motion. But probably the application of infrared that you're the most familiar with is infrared transmission and receiving. So this is, for example, how your remote control on your television or on your DVR would work. And so we're going to have an infrared receiver, which is this device right here. It's kind of hard to make it out, but that device right there is actually designed to receive infrared signals that are being transmitted at 38 kilohertz. This is the frequency that's chosen because there aren't a lot of sources of interference at 38 kilohertz, and so therefore we can really just look at that one frequency, and it'll allow us to significantly increase the range. Whereas we might be able to go a foot. If we had just a regular infrared signal, we can go 20 feet with a 38 kilohertz signal. You can imagine how useful it would be if the TV remote had to be 1 foot from the TV. So whoever came up with the modulation frequency was very clever and probably earned quite a bit of money for it. We have a little remote control right here that's going to be with each lab setup, and it has 21 separate buttons. If I turn on the serial monitor and I press a button, then I should be able to see what is the name of that button. And so this is a program that is taking the hexadecimal code that's being transmitted by this remote control, and it's associating it with each of the buttons. And so I can press all of these different buttons, and I can get the signals associated with each. Now, all that this program is doing is displaying that to the serial monitor, but there's no reason why I couldn't do something else. It's no reason why you couldn't have this control some sort of an arm or control some sort of a robot or do something, which of course is what many other applications of remote controls do. But in this case, it's just transmitting, receiving, and displaying the signal. Now, what would be really great is if we could take that signal that we just received and then learn how to transmit it ourselves. And that's actually what this guy right here does. There's a little infrared transmitter right here. It's a little clear LED case, just like the clear LED case over here. And this infrared transmitter is going to send a signal anytime that I press the button that's right next to it. So what's happened is that the receiver is going to receive signals, and when it receives those signals, it's going to remember what the most recent signal was, and then it's going to transmit it whenever I press the green button. So if I press, say, Enter Save, well, let's do up. Up is easier to recognize. Now, when I say, okay, whatever the most recent signal that I received was, I've now remembered that, and I'm going to transmit it anytime I press the green button. And so the serial monitor says, yep, I'm sending that code. And in fact, I'm showing you what the hexadecimal value of that code is so you can be sure that I'm transmitting the correct code. And so you have to take my word for it that it's actually transmitting this infrared signal. Okay, you don't want to take my word for it, then I'll show it. I'll show it to you. I'll prove it to you. The way that you'll prove it to yourself is you'll partner with another team, and you will transmit and they will receive, and then vice versa. But in order to overcome that, what I've done is I've set up another board that has also an Arduino and also this 38 kilohertz receiver. It doesn't have to be so close, but I'm trying to squeeze them all onto the screen right here. You won't need to worry about this, but I need to switch over to COM9 because that's where my other board is located. So this board, the full board, is on COM8. The receiving only board is on COM9. And then if I open up the serial, well, let me go ahead and re-download the program, and it's downloading it onto the simplified board, onto the partner teams board. Transmitting, and it's done transmitting. Now I'm going to open up the serial monitor, and let's just verify that if I press the buttons here, I can get the same behavior that I was getting before. So this, in fact, is correctly set up to read whatever is on the infrared receiver. Now, my contention to you was that when I had set this board up, the full board, that any time that I press the green button, it's going to transmit that signal. And so, if that contention is valid, then when I press the green button, it should show the word up on the serial monitor. And I'm having some trouble with this being loose, so let me try to adjust that just a second here. If you don't have a good connection, then it isn't going to transmit. So there's the up, and there's the up. So as I'm pressing the green button now, I am in fact transmitting not with the little tiny remote control, but I'm transmitting from one board to the other. And every time that I press the green button, board number 1 is transmitting, and board number 2 is receiving, and we're seeing that it's getting the signal correctly.